Okay, here are some short answer questions. Make sure you always read. For the sake of time, I'm not going to, but please make sure you read all this. And it says, explain why the formula for tetraboric acid, which I will find. Tetraboric acid is right here. Why is it an empirical formula? Empirical formulas is empirical because the subscripts are, sorry, that's an S, the simplest whole number ratio. Simplified form, empirical formula. Base your answers on the following. Determine the GFM of the aluminum sulfide product. So that's the product, whatever you produce, right sign. So we need to figure out what the masses are from periodic table. I'm not going to go to periodic table on my screen. I'm going to just go in my life here. So this is a 26.9, so that's 27, and sulfur is 32. However, there are multiple atoms. So 27 times 2 is 54 for aluminum. And I'm going to add that to 32 times 3, which is 96. So I'm going to add those together, and I'm going to get 150 grams per mole. It's a 5. This one, you don't need to actually solve. It just says, show a numerical setup for calculating the number of moles of that. So this I will show you in the reference table. Mole calculations are right here. So it's given mass divided by gram formula mass. So the given mass is 546, and you divide it by GFM. Don't solve it. You can also write it this way. Dimensional analysis, 546 grams. And then we say 1 mole is equal to 248 grams. And then you would be able to cross those out. Don't solve it. Now, there's all of this stuff, and it says, show a numerical setup for calculating percent composition by mass of water in the hydrated compound. So let's go back to reference table and show percent composition is right here. Mass of part over mass of whole times 100. So back here, part over whole times 100. So in the lab, I'm looking through, it says, let me look, I'm reading. It says I have 5.06 grams of the hydrate. So that I know is the whole. And it says that I heated it, and then all of a sudden it's 2.47 grams. So this part had water, this part didn't have water. So let's subtract those, 5.06 minus 2.47. So that's 2.59 over the whole times 100. You can also just say 5.06 minus 2.47 over 5.06 times 100. You don't actually have to do the subtraction up above. And number 1 says, show a numerical setup for calculating the percent composition by mass of oxygen. It gave you the whole GFM, so the part over whole times 100. The entire GFM is 102, but it's just asking for oxygen. So oxygen is 16 as found on periodic table, but there are 3 of them. So 16 times 3 is 48 times 100. Or you can also say 16 times 3 over 102 times 100. And do not solve it. Do not solve it. All right. If you have any questions, please reach out. Thank you.